Hey everyone, Geek37 back with another video, and this is part 16 in my exploring heptagonal triangle series. And today what we're going to do is we're going to cover the sum of the three tangents from that triangle: tangent of pi over 7 plus tangent of 2 pi over 7 plus the tangent of 4 pi over 7, and it is going to give us an interesting result, and I'm going to explain how that connects to one of the last videos I did. So what we're going to do is we're going to start off with changing out the tangents into their associated variable ratios. So tangent of pi over 7 was a squared over rb plus b squared over rc minus c squared over RA. And of course, those last two ratios are the ratios associated with tangent of 2 pi over 7 and tangent of 4 pi over 7. And let's remember that A, B, and C are the lengths of the heptagonal triangle. They're opposite the angles pi over 7, 2 pi over 7, and 4 pi over 7. And R is the length of the circumradius of the triangle. Now, what we're going to do on the next line here is we're going to change out A squared, B squared, and C squared with their associated Ptolemaic identities, which I have used in numerous videos before. And the thing is, I have proved those early on in the series. So what happens is, to begin with, let me erase this. I'm going to factor out 1 over r from those three ratios up above, because 1 over r is what they have in common. And we're left on the inside with a squared over b plus b squared over c minus c squared over a. And now I'm going to switch those out with their associated Ptolemaic identity. So a squared will equal c squared minus bc over b plus a squared, a squared plus ac over c minus b squared plus ab, put those in parentheses, all over a. And to save space and time, what I'm going to do is I'm going to just show the algebra here. And we'll show the cancellations. So c squared over b minus c plus a squared over c plus a minus b squared over a minus b, just like so there. Okay. Now again, for space and time constraints, I'm just going to show each of those ratios that have the squareds on top. I am going to rewrite them again with their associated Ptolemaic identities, but this time they will be factored. So c squared is going to be b times a plus b over b minus c plus c minus c over b over c plus a minus a over c plus a over a minus b. And of course, what happens is we get the cancellations with the b's and the c's and the a's on those fractions. So what we're left with is 1 over r times the quantity a plus b minus c plus c minus b plus a minus c minus a minus b, just like so here. And the nice thing is we have a number of cancellations. I can cancel an a with a negative a b with a negative b, and a c with a negative c, and what I'm left with is 1 over r a minus b minus c in that particular setup. And I set it up that way because I'm going to show that a negative can be factored out from that. So I get b plus c minus a. And if you remember, b plus c minus a, I proved this in a prior video, equals the square root of 7 times r. So I can replace that with the square root of 7 times r. So the r's will cancel, and I'm left with the negative square root of 7. So the tangent of pi over 7 plus the tangent of 2 pi over 7 plus the tangent of 4 pi over 7 equals the square root of negative 7. Now, there is an interesting connection here because in one of the last videos I showed that the tangent of pi over 7 times the tangent of 2 pi over 7 times the tangent of 4 pi over 7 also equaled the square root of negative 7. So what that means is that we can write the tangent of pi over 7 times the tangent of 2 pi over 7 times the tangent of 4 pi over 7 equals the tangent of pi over 7 plus the tangent of 2 pi over 7 plus the tangent of 4 pi over 7 are equivalent to one another. And that is a special case in trigonometry called the triple tangent identity. And this only works when your angles, for example, alpha plus beta plus gamma equal pi radians. And as you can see, pi over 7 plus 2 pi over 7 plus 4 pi over 7, you add those up, you get 7 pi over 7 or pi radians. So the heptagonal triangle allows for this special case to be shown involving the tangent identities. And it's one of the only cases that I can think of where the product of three values equals the sum of three values, especially in the realm of trigonometry. I don't really know of anything else. I do know for a fact that in the world of natural numbers, 1 times 2 times 3 equals 1 plus 2 plus 3. So if there's a way you could rearrange tangents of angles to do that, that would be kind of interesting to do. But in this particular case, I wanted to show you that the tangents of this triangle, because of the way the angles are set up, lead to this triple tangent identity showing itself from beneath the waves. And I wanted to show you that today. All right, I hope you enjoyed this video. I enjoyed making it. This is Geek37 signing off.